Hi everybody, it's Rick Butts. In this video, we're going to look at conduits. And it just gives me great pleasure to show it to you. This has been one of my dreams, to be able to have a program, a software tool that would do the functions that I'm going to demonstrate to you. It looks really good. Can't wait for you to see it. Let's go take a look. All right, before we get started, I would like to cover a couple of historical documents, and then we're going to talk about some definitions. I want to talk about the problem that we're dealing with, and then how Edestol solves that problem for you with conduits functionality. This is what you would call, what many refer to as a riser diagram, where you basically describe, this is a diagram of all the conduits, and in this case we have cable tray as well, for a particular set of electrical equipment. In this case we actually even have underground conduits coming in, showing feeding from the bottom. This particular document shows a few conduit sizes, but in general they are just tagged with numbers, so there's a schedule, a corresponding schedule that goes with it, that gives you all the details of what wires are running here, what size the conduit is, what material, what the specifications are, all of that. But you can see it completely describes the conduits to be run to and from these particular pieces of equipment in this, it looks like it's labeled MCC Room South. Now here's another diagram which shows field devices. These could be cable trays up here, but they're not. In this case, we have a conduit system where you have a trunk line and then a series of drops into the particular devices that you're dealing with. And this could be any kind of a process. This could be HVAC sensors, any sort of system that you might be using, but we have conduits that are used for power. In this case, it's probably 480, but I don't really know. We are using conduits here for controls, for control cables. We have conduits here for signal cables. Each one of them is run separately. They all drop down into the same junction box, and then the appropriate either flex conduit comes out to the devices, or these could be cord connections. So you have basically a power conduit coming down. You have power, something coming from your J-box, some sort of a signal or control wire going to your device. Then you have signals and controls going to your J-box here. So you guys are all familiar with these. I have been doing these things for 40 years. And I believe that the success that I've had with issuing construction packages that have turned out to be very easy to execute, very few questions coming back to me, relates to the fact that these are part of the packages that I put out to build whatever system I'm designing. And I'm one of the few engineers that do it. They are, as you can see, very tedious. This only shows you a little bit of the actual effort to do the CAD portion of it, but you've also got the schedule, so you've got a spreadsheet, you've got calculations on how big each one of these trunk lines is. As cables drop off a trunk line, the conduit gets smaller. All those calculations, you've got multiple cables in a single conduit. Very seldom are they actual single conductors, so there's no code tables to help you sizing that. And I have actually generated over my career several different spreadsheets to do all these particular activities. Well, the good news is that Edestol does this for you. You don't have to do any drawings. It does all these, what I call, it's just in the conduits piece. It's to or from cable trays. You can use multi-conductor cable. You can use single conductor cable. You can use all the different voltages, but it actually sizes your conduits for you, allows you to run multiple cables within each conduit, and it just makes things so much easier. So without further ado, let's go look. I want to give you some more, before we actually get to the program, I want to give you some definitions. And let me zoom this out a little bit so we can look at it, fit to width. All right, so we in Edestol, the Edestol program creates what's called conduit systems. And I'm going to give you a definition of that. And you don't have to worry about it too much because once you get to it, it's fairly intuitive. But I just want to give you these definitions because this is new functionality that you have never seen in any other software. What a conduit system is within the Edestol program is it is a contiguous group of conduit segments. We'll talk about what a segment is real quick in just a minute, that begin and end at an enclosure, cable tray, load, or device. So basically it is the system of conduit that connects to all these devices. Once you get to an enclosure, if you have another conduit coming out of that same enclosure, or you get to a cable tray and you have another conduit coming out of that cable tray, that is another conduit system. They are separate conduit systems because they're divided by either an enclosure, cable tray, load, or device. So it's a group of segments that's put together to build a conduit system. All right. A conduit segment is a continuous length of conduit which begins and ends at an enclosure, cable tray, load, or device. You see those same components listed up there in a conduit system. The addition of for conduit segments, the change is that as well as another conduit segment. So what happens is when you take separate lengths of conduit and you put them together, each independent length of conduit is what would be considered a segment. The combination of all those segments connected together and connected to all the devices, the loads, the panels, that is your conduit system. Where these segments within a system join together is known as a node. And the location of a conduit system, the definition of a node is a location in a conduit system where segments are joined. This will always be a fitting. Okay, so that gives you a little bit of some definitions. Now let's look at some examples. All right, so the simplest conduit system is a single segment. All right, a conduit system goes from, in this case, we have P1, which will be panel 1, out to motor 1. So you have a single, very simple conduit system. And this has one segment because there's no nodes. It's just an enclosure and a load device. And the cable, it turns out in this case, the cable has a from and a to on the cable, the from P1 and to M1. If it's a P cable, if you're familiar with the nomenclature we use in Edestol, you probably are if you've seen the other videos, you probably have a P cable M1 in your cable schedule. And what you have is that cable has a from and it's P1 and a to M1. Now, the way we label conduit systems is we just are numbering them. They don't really have any definition tied to a particular enclosure. They are, as with cables, with power cables or with any cables, there is the first letter, which is either an M or an N for your higher voltages, P and an L for both your power range voltages. You got C's for control cables. So if you're doing a conduit with a control cable, it's going to be C conduit 001, and we just do them sequentially. Each conduit system is defined by a single or more than one segment. So in this case, there's only one segment. The way we identify segments is the start of the segment number, and then the end of the segment, and they are divided by colons. So basically this segment is up here is labeled P1 1 colon M1. So that is your segment tag. And just a couple of ideas, a couple of thoughts here. Cables have from and to locations. Segments have starts and ends. So this start for this one segment is P1 and the end is M1. And the segment tag is P1 colon M1. So it's segment number 1 that starts at P1 and ends at M1. Now, The way you create cables is you just drag one of the cables down to the actual header that's of the conduit area that says conduits. It will then create a conduit system, and it will give it one segment, and that segment will be number one. And it'll be when you create a conduit system, your first segment defines what we call as the start location for the conduit system. All right, so P1 would be start. In this case, you'd have one segment. M1 would be the end for that particular segment. Now, let's go on by dragging. Let me reduce okay, so what you see the P1 to M1 there, that was our single segment system. But now what we've done is we have dragged another P cable or another control cable or whatever that matches the same type of a conduit system as you've already created onto this system. So there was a system, it was labeled 001. You drag the cable from your cable schedule down to that system and said, okay, we're going to add that cable to the conduit system. What that did and that cable was a P cable M2. So they both started with P1. You already had this segment here. What we're now doing is when you add that, it basically gives you a branch and a node, and it gives you, rather than one segment, which was just to M1, you've now created a segment from node A to M1, and you've created another segment from node A to M3. And you've changed the segment that already existed from P1 to M1. Now it goes from P1 to A. Now what the software does for you is it knows that. It knows now how many cables are in each segment, and it sums up the area, and it adjusts the size for each of these segments as appropriate. As you can see, nodes are labeled with, we just label them with A's. Basically, we have a few rules about creating conduit systems, and that is for all conduit systems where you don't have a cable tray, each cable may exist in only one conduit system. So if you took this M1, P cable M1, and created this system, then created P cable M2 and put it into this system, and you now have this conduit system with 3 segments, and you took P cable M1 and you dragged it onto conduits to create another system, it would say the cable is already being used in a conduit system. So you can't create another one. So you're not able to reuse your cables. It kind of helps you keep from creating too many conduit systems. Now for cable tray systems, which we're not going to cover in this particular video, you obviously need a conduit coming from your source device up to the conduit, and then you have a conduit coming up to the cable tray. Then you have a conduit coming from the cable tray down to the device. So in that case, for cable tray systems, you are allowed to have 2 conduit systems containing a single cable. Now, let's look at what happens now. So let's back out of here. So in this case, now you have added 3 cables. You have a P cable M1, you have a P cable M2, and you have a P cable M3. You created the first one, and then you dragged M2, which created the previous diagram. Now you added M3. So now you have 3 cables in this segment right here. You have 1 here. You have 2 cables here, because now you're covering M2 and M3, and then you have 1 in each one. And what you will see as we create this, you have a tree view for this system. And you now have 5 total segments. You have a segment from P1 to A. Here they are down here, P1 to A, and that's segment number 1. You have A to M1, and that's segment number 2. Then you have A to B, and that's segment number 3. Then you have B to M2, and that happens to be segment number 4. And then you have B to M3, and that happens to be segment number 5. And as you do that, what happens is that The program now knows you got 3 cables here, you got 1 cable here, and they could all be different sizes. Obviously this could, M1 may be 4/0, M2 may be number 1s, M3 may be number 12s, and it will calculate your conduit segment sizes based on the cables that are run through those individual segments. So there you go there. The rules, you have a couple of rules for adding segments. Basically, the cable has to have something in order to drop another cable on this system and have it work, have it be installed and create another segment and another branch. It has to have something in common. So let's look at another cable. You have another cable that says P2 to M4. Well, there's M1, there's no endpoints on your either the start or the endpoints of this conduit system that is in common with this cable. So if you drag P cable M4, which goes from P2 to M4 into this conduit system, it will say you can't do that. There's nothing in common. It does not know where to put the conduit. So basically that's part of that. So you can't do that. You can't put cables of different cable alphas. You can't put N's and M's with P's or L's or C's or S's. These all have to be, and you will be creating conduit. You will have sub branches by cable alpha designators, and you'll see that here in a second, for each area of the conduits that you are creating. And then as you can see, you have to have something in common. So you couldn't add this cable to this conduit system. So there has to be something in common. Now, when we're not talking about it now, but if you had a cable tray, the cable tray would be, if you were running both cables through the same cable tray, that would be common. So you can have, with cable trays, you can have cables coming out of P1 and P2 into the same cable tray. Then the conduit that comes from the cable tray down could do M4, 3, 2, and 1 together. So, because then you have the cable tray in common. Right now we're just just demonstrating single conduit systems. Once you get used to this, then we'll move on. I'll do another video for cable trays. So that kind of covers the basics of the way the program deals with this new functionality that I have developed. This basically allows you to create riser diagrams in a drag and drop method without all the tedium that goes along with it. So let's just close these up, and we'll just close it up, and we'll close this one, and then let's look at our program. Okay, let's call up open, and this is our import. We did some imports of controls and power on a previous video. We created our power devices. Right click here and let's do expand all branches. So there you go. You got an MCC1, you got an MCC2 down here. You got all these cables, all these power devices. You got an ASD, circuit breakers and stuff. So we have created a whole power model there. We have added control devices. We have 2 remote IO cabinets. Our PLC cabinet happens to be here it is right here. It's fed from a distribution panel in the power model. So we've got a PLC cabinet, we've got an HMI, and let's just, I don't know no, you gotta open them individually. Okay, so there you go. So these are your different devices. Under these subheadings for controls are your control device types. So these are control stations. So you've got 6 control stations. These are annunciators. So you got 2 alarm horns. You got 1 just miscellaneous panel. You got a network. In this case, it's a network cabinet. You got an HMI where we're calling it operator interface terminal. You got 2 remote IO cabinets. And then you got terminal boxes. You got solenoid valves or actuators. You got switches or limits, elements. So you got all these different types. So as we created these, as you recall from the video, we created all these cables. All right. So now what we're going to do is we have this section of conduits down here, and let's just create some conduits. All right. So what I'm going to do is as you recall, the M1, M2, 3, 4, 5, and 6 are all from, if you look at our cable schedule, okay, our froms, actually let's look at cable restways. This kind of gives you a from and a to. So basically, we're going to look at these M1s. The M1 motor is big enough that it takes two. I think that was a 500 MCM or KC mil, and we decided to make it smaller, so we divided it into two parallel runs. So there's your two parallel runs for your, goes from your disconnect switch, local disconnect for M1 out to, no, actually it goes from your ASD out to your disconnects. This one goes from your disconnect to M1. So let's just do M1 through M6. Okay, so we're going to select this with a shift select standard, and we're going to go down to, and we're going to drop it in conduits. Now here's what it does. It says P conduits. It knows that you've got parallels, so it's going to give you the P conduit 001. This is the first conduit. It's assigned that number, and it knows that it's parallel run, so it gives you an A. It's not going to show you B because you just deal with one, and it always either deletes one or it deletes them all together as a group. These specs on what cable, what type of raceway you wanted to use, you can change them here, but they are set. It carries over what you put on the cable form. So there you go, you got a 40% fill. So this is the cable tag that you're doing right now. I'm going to press save. Then it goes, it did B. I'll show you here in a minute. Now we're on to P conduit system 002, which is from MCC1 to M2. Again, it's liquid tight flexible metallic conduit. Did 3, 4, 5, and 6. So you now have created conduits. This is what it looks like. You have a conduit system. And I gave you some right clicks because we're going to collapse all segments. This shows you just your conduit systems. If we do a right click here and expand all branches, this shows you your conduit system. You can see P conduit 001A, and it has a parallel P conduit 001B. It starts from DS disconnect switch M1, it's segment 1, and it goes to motor M1, and it contains P cable M1A, okay? These two are together, so if you deleted those, the way you delete a conduit system is you delete one segment at a time, and then when you've deleted the final segment, the conduit system goes away. So we could delete it by just doing a right click on this segment, and it'll say delete conduit segment. Well, we're not going to do that. So now let's go up to our P cable list and look at raceways. And you can see over here that our conduit system has been filled in. So here's our P conduit system. We just did these in order. So it gave you system 1, parallel A and B, then system 2, P conduit system 2, 3, 4, 5, and 6. Okay, so now let's do our feeders to our MCC. All right, you can take them down and just drop them in conduit. It'll put it in the appropriate P conduit or L conduit, creates whatever. And see, you can see it's creating another parallel run. This is the feeders from the main switch gear to the MCC1. Okay, this is your feeders. So there you go. So and then we did 8, and you got 9 down there. So now you've got all the way down to, 7, 8. Yep, just 2 different ones. So let's go back to our P cables. So that's the way you do that. It gives you a size, a fill limit, a size. It gives you a quantity of all the conductors in that particular segment, but it also says how many power conductors are in that segment. And what we are using that for is to, if you do say 6, if you do 2 cables together, so you have a total of 6, it will, if your segment length is longer than 2 feet, it will go back and issue a warning for your cable, and you need to rerun your cable form for that cable, and it will go in, and rather than, it will adjust your ampacity, derate your ampacity based on 6 power conductors in a conduit. So I'll demonstrate that a little bit later, but that's the idea about what these power conductors are for, is keeping track of which power conductors are in each segment. So there you go. So here's all your cables. So we're looking at a cable list. No, excuse me. We're looking at a conduit system. If you look at an individual conduit system, it will list all your segments. So we're going to actually go down, and the next one we're going to do is we are going to do our E-cables. So we've got, from the PLC, we have 5 sets of Ethernet cables run out to these devices. This is EFF 101, which is it's just a display panel. We got Net 902, which is our network cabinet. You got OIT1, operator interface, RA1. So let's just start. In this case, we're going to put these cables together. Okay, this is not power where you got a bunch of single conduits running to a big load. This is where you typically run all your Ethernet wires in a single conduit trunk, and then you drop them down. So this will give you, and you do a little bit, it's kind of a hybrid in between. Your controls and your signals are kind of somewhere in the middle between power, which is generally 1-to-1, and then communications, which is basically usually just a trunk line with drops. So let's just start. We go from the PLC, it hits RIO1 first. So let's create that conduit. All right, so that's exactly what's happening. It's coming from segment start PLC to RIO1. It's only one, it's two cables. So you see that 31%, which is the fill limit for 2 cables. Okay, so we're going to say okay there. Then we're going to go, next thing we want is RIO2, and we're going to drop it on that same conduit system. And it's going to say fine, PLC to RIO2. And again, it's just 2. I was running 1 Ethernet plus a spare. So you got 2 wires, so you're allowed only 31% filled. Now, you see what happened here is that you now have a segment, which is PLC 1 to node A. Okay, PLC 1 to node A. Let's look at the whole thing. You have PLC segment 1 to node A, and it actually has 4 conductors in it, okay? And you'll notice that rather than 31% fill, when you added that, when we created segment 1, it was only 31%, because it only had 2 wires in it. So when we added that other set of cables, it now has 4, so you're back up to 40%. So it's recalculated the fills in all these segments. So now we're going to do the next 3 of these just in order, okay? And we're going to just take these, and we're going to say we want all these on our on that one system, okay? And in this case, I only ran 1 Ethernet cable, so you can do a 53% fill, all right? You don't have to use them. If you want to adjust those numbers, you can. There's our Net 902, and there is our PLC to OIT, okay? Okay, so let's make it a little easier to see. So now basically here's what you've got. You basically have all 5 of these in segment number 1 going from, we'll look at the conduit system first up here. And you can see if segment 1 goes from PLC to node A, okay? And there now happens to be 11 unshielded twisted pairs in that conduit, okay? And then you have segment 2 is from that node. Your first drop is to RIO1, okay? Since there's only 2 there, there's only 2 conductors. In these cases, since we're doing Ethernets, there's no power conductors in here. So this functionality is not used, but we got the same report. So you're dropping off of A and going to RIO1. From A to B, you're basically dragging 9. So you got 11 minus 2, you got those 9. And you basically are up to 40% fill, and it has sized your trunk line for you. Then A to B, which is down to 9. Then you've got B drops off to RIO2. In this case, we happen to have a 1/2 inch, which is the minimum size for an RMC. You've dropped 2 off of that trunk line. Now you have 7. Then you're dropping 1 to your efficiency panel. So now you got 6. So basically, and then from C, you go to D, excuse me, from C to D, and then from D, you drop to NET 902, and then from OIT 101. So you basically have a drop going to each one, and you can see what's happening in your tree over here. This last node here drops from, this is segment 8, which goes from node D to NET 902, and then from node D to OIT 101. Now, here's the cool thing about it. You know what? This is just kind of a star configuration, and it turns out we need to run an Ethernet cable from RIO1 directly to OIT 101. So we're going to go up to our manual cables. All these cables were created when you brought the device, when you created the device in the controls area, or when you created power. You had a actually you had to add the Ethernet when you were in the controls area. So you've created all these cables. These are called auto cables. Now we need one more that we haven't created yet. And so let's go up here to cables, and we're going to create another E cable, and we're going to put it in cables. And we're going to say that is, what did we say? That goes from OIT 101 up to RIO. So let's go OIT 101 to RIO 1. Okay, and it's going to be 4 pair, and we're going to do 2 quantities of unshielded twisted pair, Cat 5e, 4 pair. There you go. So, oh, okay. So I've created. I just did this, and it automatically said your to address is assigned to E cable, and that's your cable tag. Well, in this case, no. Because we already have that cable, and that cable we've already installed. So in this case, we have to create another cable tag. So we're going to call this OIT 101 underscore RIO1. So we're adding a new E cable with a unique cable tag, and let's save that. Okay, and then let's go to cables, and you can see that's it right here. Okay, so this is our new cable. So now we're going to take this and we're going to drop it into this same conduit system. Okay, and in this case, it's not going to create new branches because it doesn't need to. You have a conduit system going already from OIT 101 all the way up to RIO 1. So it drops it in there. I'm not sure we need, in this case, we don't need this. So this is something we'll change. We'll take this out because we don't actually need this. Because but look at what it's done now. It has added that cable in this segment that goes up to the node, and then it's added that cable from node to node. Then it goes from node to node, then from node to node, and then it sees the drop to RIO1, and it drops that cable down in there, and it has recalculated the cable sizes for all these. So you basically, your eConduit system 101, let's click on that, now has same number of 9 segments, but now rather than 11, 11 didn't get to the top, right? Now basically rather than, it was 2 and then 9, so now you added 2 for every segment that new cable goes through. So you now have an ability to just drag and drop and create those riser diagrams, or I actually kind of call them conduit schematics or whatever you want to call them, but you have the functionality as either a contractor or an engineer or an estimator to literally define your entire raceway system from a conduit sizing standpoint. You get down here to bill of materials, and if you look at conduits, this is a very general form right now, but basically it tells you how many different segments of each size and type of conduit that you have in your job. And you go back up here to cables. So let's look at our total cable list. Actually, I think you can see, oh, I forgot. I got to make cables for these. I got to put these in conduits. So basically, if they're supposed to go in cable trays, you can see that they're in cable trays. Oh, there's your entire, yeah, there you go. So there's your entire cable schedule. And you could look at it this way to actually see more of a definition of what the cables are. Some are multi-conductor, so you only got one 3-conductor. Some are single conductor, so you got one conductor, number 14 neutral, number 14 ground. You know how all these work, but you also have this conduit system that says, this gives you a real nice way to make sure that you have raceways for every cable that you've done. You can basically look at your power devices, make sure everything's covered. You should have a motor list or a load list, and you should have all your motors. Look, you got a 50 horsepower, you got a 25 horsepower, you got 100, 150, 200, 250. So you can count your motors, make sure you got all those covered. Make sure you got all your transformers done. Then, if that's done, just make sure your cables are correct. And then make sure your cables are in conduits, and now you have a real accurate definition of your entire cabling and raceway system. So that has really been my vision, is to just get us off of the spreadsheets and to get us onto a database platform. That's what Edestol does for you. Hope you can see the power in this, and just really appreciate your attention. Probably went a long time, but as you can see, it couldn't be avoided. So we will catch you on the next video real soon. Take care. Bye.